Welcome. This is Raina Fitzgerald, and in this lesson we're going to add and subtract rational expressions that do not have common denominators. Let's take a look at the least common multiple, or LCM. The least common multiple, also known as the least common denominator, is the value such that both denominators multiply evenly into the least common denominator, or least common multiple. So 3 and 5 would be facts of this value. And so if we take a look at 3 and 5, well, 3 is equal to 1 times 3, and 5 factors into 1 times 5. I'm sort of spreading these out. And when we're finding the least common multiple, or least common denominator, we take all the facts that not only that they have in common, but we multiply all the facts, 1 times 3 times 5. If a fact occurs in both of them, we only take it once. So it's 1 times 3 times 5, which is 15. So 15 is our least common multiple. Okay, let's move these up. So the least common multiple for this expression is, for this sum, for these denominators, is 15. So we'd multiply the top and the bottom by a 5, because 5 over 5 is 1. That gives us a 15 in the denominator of the first rational expression, and the top and the bottom of the second rational expression by 3, because 3 over 3 is 1, and then again that gives us a 15 in the denominator. And we end up with 2 times 5 is 10, over 3 times 5 is 15, plus 4 times 3 is 12, over 3 times 5 is 15, and we can finish this off because now we can add them together. They're both over 15, and 10 plus 20 is 22. Now let's try another. What if we have, we want to find the least common multiple, and what we have, say, is a 2 over 9, and we're going to add this to 5 over 12. Now we can't add these fractions together because they don't have a common denominator. So we're going to need to find the least common multiple, or least common denominator, between 9 and 12. So let's take a look. 9 is equal to 1 times 3 times 3, and 12 is equal to 1 times 3 times 4. So the least common multiple, well, we take the 1, and you can sort of skip the 1. I suppose that's not quite as necessary. Everything's a multiple of 1. They both have a 3, a fact of 3. One of them has a second 3, and we've got to take all facts. We only take them once if, see, we have 9 has the first 3, 12 has the first 3. We only take that 3 once. But the second 3 that 9 has, we also have to take that. And then the 12 has a 4, so we have to take the 4. So our least common multiple is 3 times 3 times 4, which is 9 times 4, which is 36. So our least common multiple, or least common denominator, is 36. So let's continue this. And so our first fraction, which is 2 over 9, in order to have the denominator be a 36, we have to multiply the denominator by a 4, because 9 times 4 is 36. But if we multiply the denominator by 4, we must also multiply the numerator by 4, because 4 over 4 is 1. Now we take the 5 over 12. And what must we multiply 12 by to get a 36? And that's 3. 12 times 3 is 36. But we must also multiply the numerator by 3 because now 3 over 3 is 1, and we don't want to change the value of that fraction. Okay, so 2 times 4 is 8, over 9 times 4 is 36, plus, and the next fraction, 5 times 3 is 15, and that's over 12 times 3, which is 36. Now I have a common denominator, and the common denominator is 36, and in the numerator I can add 8 plus 15, and 8 plus 15 is 23. So my answer is 23 over 36. So let's box our answer here for our second addition problem, and let's box the answer here for our first addition problem. And so this section was to help you understand the least common multiple or least common denominator. And now we're going to look on our next slide at what happens when our denominators have variables in them. Okay, these that are not just constants, but polynomials to higher degrees. Let's take a look at this example problem. The first thing that I would do here is change the subtraction to add the opposite. And if I put a parenthesis around this numerator, when I add the opposite, I'm adding the opposite of the entire numerator. Okay, let's put parentheses around the denominators as well, because they are binomials. We want to group them together. And what we want to do is we want to add these together, and we have to start by finding the least common denominator, or least common multiples. So I start by moving our expression up, and let's write our first rational expression, which is x plus a negative 5, and we'll put that in parentheses, over x plus 8 and here our least common multiple will be x plus 8 times x plus 4. So I need to multiply this rational expression essentially by a 1, but I'm not going to write it in terms of a 1. I'm going to write it as a ratio of x plus 4 over x plus 4. That's equal to 1, and I don't change the value of the original rational expression because I've actually multiplied it essentially by 1. Now I'm going to take my next rational expression, which is, let's distribute that negative sign in, this negative sign, to the x and to the 7. And so that's going to be a negative x plus a negative 7. That's my numerator. And in my denominator, I have x plus 4. And I'm going to multiply this rational expression essentially by a 1, but I'm not going to write it in the form of just 1. I'm going to write it as the ratio of the same expression, which is x plus 8 over x plus 8. And that gives me a common denominator. Both of these ratios or rational expressions, we have two of them, our first rational expression and our second rational expression, both have a denominator of x plus 8 times x plus 4. All right, so let's multiply these two rational expressions. And when we do that, well, the denominator, I'm going to leave the denominator factored as x plus 8 times x plus 4. And the numerator, I'm going to use distribution to multiply x plus negative 5 times x plus 4. Well, x times x is x squared, plus x times 4 is 4x, and a negative 5 times x is a negative 5x, And then negative 5 times 4 is a 20. And certainly we're going to need to add these two terms together because they're like terms. Now let's do the next fraction. The denominator will commute, is x plus 8 times x plus 4. And I'm just commuting so it looks just like the denominator of the other rational expression. And then in the numerator, I'm going to say negative x times x. That's a negative x squared plus, I'm distributing, a negative x times 8, and that's a negative 8x, plus a negative 7 times x, and that's a negative 7x. So let's write this 7x there. And then we're going to distribute the negative 7 to the 8, and that's going to give us a negative 56. And let's pull our little bar over here. And in here we can see that we're going to have to add together the negative 8 and the negative 7x because they're like terms. All right, so coming down below, what we have in the numerator is x squared plus a negative x plus 20. And what I'm going to do is I'm actually, as I simplified this by adding the 4 and the negative 5 together. That gave me my negative 1x. And because the denominators are the same, I've simplified the numerator of the first, and I'm going to right away go right in and add to that the numerator of the second. But as I write it, I'll simplify it, and I'll start with a negative x squared plus, and here I have a negative 8 and a negative 7, and let's see, that's a negative 15 times x. And then the last term here is a negative 56. And this is all over our common denominator. And so what we want to do now is if we look at this, we can see that we have an x squared, a positive x squared, and a negative x squared. They cancel out. And I end up with, let's see, there's a linear term here. We have an negative x squared and a negative 15. I'm sorry, that's a negative x and a negative 15x. And when we add those together, we get a negative 16x in the numerator plus, and here we have a constant term of 20 and negative 56. And if we add those together, that gives us a negative 36. And this is all over our denominator, x plus 8 times x plus 4. Now let's factor the numerator. The greatest common factor in the numerator is a negative 4, and it's a negative 4 times 4x plus 9, because 4 times 4 is 16, and 4 times 9 is 36. And this is all over x plus 8 times x plus 4. Now when we look at this solution, the numerator is fully factored. It's a negative 4 times 4x plus 9, and the denominator is x plus 8 times x plus 4. This is fully factored. The numerator is fully factored. The denominator is fully factored. There are no like facts, so nothing is going to cancel out, and this is our final answer. And you can write your answer in a fully factored form, or you can multiply everything back together and express the numerator and the denominator as a polynomial, as a sum of terms. Either way, you're going to have the same answer. The reason, again, for factoring is to see if anything cancels out. In this case, nothing does, and this is our final answer.